You ever heard of this one? Can you make it land a little heavier?
Ah!
Don't worry, I got you. Let's talk about
Isaac Newton!
Alright, let's talk about Newton's laws. Let's go over it really quick. The first one, let's go. An object at rest stays at rest, and object in motion stays in motion. Well, all that means is if something's sitting there, it's not going to move. If something's already moving, unless something stops it, it's still going to be moving. Then, for every action, there's equal and opposite reaction. Well, all that means is one thing hits another object, the object that got hit has a reaction. It's as simple as that. And then the formula itself. Force equals mass times acceleration. Got all scientific math on you now, so don't have to pull out a calculator. It's just a simple relationship. Something really large moving slow can equal the same amount of force of something small moving very fast. So it's just a relationship of size and speed in a nutshell. Let's start off with the box. If you were to guess what was in this box, you'd probably guess that it's pretty light, watching it bounce pretty freely, defeating gravity. Now let's introduce another one. This one seems a little bit heavier. It seems to struggle at defeating gravity, not as easily as the first one. Let's keep going down that path. Introduce another box. Even less movement, less bounce. Gravity is definitely defeating it. But something is off, something's missing. Going back to those Newton laws, you can see that, well, even though we know that all of them have some power in there, because we have weight, mass with the acceleration, but what about the transfer of weight? Where does that power go? Perhaps it's not represented here. One easy way to do this is just showing the effects of where the power is. When it collides with the ground, the power has to go somewhere. An easy one here is just to introduce rubble. Some sign of where that momentum has gone. We learned about Newton's laws, all three major ones that really apply to animation. We looked at boxes and progressively showed some forces that represented power with mass and movement. And we also showed the transfer of that and how to represent it. Any questions and comments, just post them up.